So here in this problem, we need to show that the points given by 2, -1, 3, 4, -2, 3, and -3, -2 form the vertices of a rhombus. So let us begin. So let us consider we have a rhombus with vertices A, B, C, and D. And we will suppose that the coordinate of A is 2, -1. Coordinate of B, let it be 3, 4. Coordinate of C, let it be -2, 3. And coordinate of D, let it be -3, -2. Now, in order to show that ABCDs are indeed the vertices of a rhombus, we'll have to show that the sides are of equal length. So we'll begin by finding out the length of each of the sides. For that, we will be using the distance formula. Let's say we have 2 points, point A and point B, whose coordinates are given. Then if we join point A and point B by the help of a straight line, then we can obtain its length by using this particular formula. All we have to do is take the square root. Underneath the square root, first what we'll do, we'll take the square of the difference of the x coordinate, x2 minus x1, and then add it to the square of the difference of the y coordinate. So we will get, now it will start with the length AB. So AB will be simply equals to, we'll take the square root, and we'll have to take the difference of the x coordinate and then square it. So we'll start with the x coordinate of B, so that's 3. From it, subtract the x coordinate of A, so that's 2. So we have 3 minus 2, we're going to square this value. And then we are going to add it to difference of the y coordinate. So here we have 4. From here, we are going to subtract the y coordinate of A, so that's -1. So we have 4 plus 1 whole square. So let's obtain this value. This comes out to be equals to square root of 26. Now we'll try to find out the length BC. So BC is going to be equals to, we'll take the square root. Underneath the square root, first we will take the x coordinate of C, so that's -2, and from here we're going to subtract the x coordinate of B, so that's 3. So we have -2 minus 3 whole square. To this we are going to add the difference of the y coordinate. So we'll start with the y coordinate of C, which is 3. From it, subtract the y coordinate of B. So we have 3 minus 4 whole square. So this gives us a value square root of 26. We can find out CD. So CD is going to be, take the square root. Underneath the square root, we'll take the difference of the x coordinate first. So we'll start with the x coordinate of D, that's -3. From here, subtract the x coordinate of C. So we'll get +2 whole square. Added to it will be, so we'll take the y coordinate of D, so that's -2, and from it subtract the y coordinate of C, so that's -3, and then square this result. This is going to give us a value square root of 26 as well. And then finally, we can find out the length dA. So dA is going to be simply take the square root. First we will do 2 minus of -3, so that's 2 plus 3 whole square. Added to it will be -1 plus 2 whole square. So this is also going to give us the value square root of 26. Now clearly we see that since AB equals to length of AB equals to length of BC equals to length of CD equals to DA, that this implies that the points A, B, C, D forms are the vertices of a rhombus. So that means A, B, C, D is a rhombus, hence proved.